So this is Algebra 1, Semester 1, and it's the third unit called Graphing Linears. It's the 15th lesson called Writing Equations of Parallel and Perpendicular Line Practice. It's on CreatorMath.com under the Algebra 1 tab. You might have to Google CreatorMath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from CreatorMath.com. So it can be difficult to find those notes. I'll try to show you how to do that right now. There we go. So here's the website name, CreatorMath.weebly.com. Type that into Google, and if you do, hopefully you get to this home page. If you're on this home page and you have any questions about the composition book, even late into the semester, students will be asking about the composition book. Please just scroll down, okay, to where it says composition book, right here, and you will see, read all the directions, watch all the videos, adhere to the turn-in dates, and put things where they belong. And as long as you got notes on there, you should have a 90 to 100% on your composition book. Now, you do need to go into the tab of the class you're in, or in this case, the video we're making. So this is where you'll find the vocabulary, the notes, the practice sets, which we're doing one now, and the videos like we're making right now. So once you find this, in fact, if you're not getting 100% on your vocabulary practices, you might not know that there is a full PDF of all the vocabulary we use for the entire year, and it is downloadable to your device and searchable. Just Google how do I search a PDF with whatever type of device you're using. It is a little bit different per device. Okay, then we're going to find the semester we're in, or in this case for the video that I'm making. Under that you'll find the table of contents. They're very important, so important that I try to get you to write all of them, all 3.5 pages of them, into pages 2 through 6 of your composition book. Why are they so important? Because they tell you where everything goes in the comp book, right? All the page numbers are listed there. So next thing we're going to find is the unit for this video, and we're going to scroll down till we find that. For this particular video, it's graphing linears, and this is lesson 15. Those are all different lessons here. We're going to go down and find that one. This one happens to be writing equations of parallel and perpendicular lines. Here are the pages on which the notes go. Please don't take this video's word for it, but go back and find the original table of contents at the time you're viewing this. Probably these page numbers might have changed, all right? So here will be the notes. We'll open that in a second. The problem set is the one we're doing now, and the video solution should be tagged here as long as everything goes right. So sometimes it takes me a couple times to open these notes, but this time they open the first time. You're going to put these notes into those pages on your composition book. This is talking about parallel lines, how parallel lines have the same slope. All right, so given that this is the 15th lesson of this unit, most students are well versed on slope by now. If not, it goes over again. It's rise over run, right? If this is up 1 and over 1, and this one has a slope of 1, 1 over 1 is 1. If this line has a slope of 1, and this has a slope of 1, and this has a slope of 1, they must all be parallel. All right, and that's pretty intuitive for students. Students can usually prove that in their mind intuitively, right? All these parallel lines have the same slope, m equals 1. It gets a little bit less intuitive when you talk about perpendicular. So parallel means, you know, they run in the same direction and they never cross or touch, right? And more technically speaking, they lie in the same plane, which means they're flat with each other. They're not skewed. So two lines that go like this never touch each other, but they're not parallel because they're not in the same plane. They would have to be like this to be in the same plane. All right, so perpendicular lines cross at 90 degrees here. And for these, it's a little bit more difficult for students to understand. This is something we call the negative reciprocal. So two things are going on here. A reciprocal to a fraction, say the fraction's 1/2, flipping it gives us the reciprocal. So say the 2 is in the denominator position here, now it's in the numerator. The 1 is in the numerator position, now it moves to the denominator. That's called flipping a fraction, or the reciprocal means to flip it. And then the other idea is negative. If we start with a negative 1/2 and we multiply it by another negative, then it would make it positive. Likewise, if it was positive and we multiplied it by a negative, it would become negative. So To find the slope of perpendicular lines, we need to both flip the fraction, which is called the reciprocal, and multiply through by a negative. So we call it the negative reciprocal. So make sure this is in your notes, and we'll talk about that as we go through the problem set. Here's a definition of parallel: lines which never touch or cross and lie in the same plane. A plane is a perfectly flat surface. Perpendicular lines which are lines which cross at 90 degrees and lie in the same plane. Reciprocal means to flip a fraction, and negative means to reverse the sign. All right, so those notes will help you with a little bit of background when it comes time for the problem sets, or if we discuss them, that'll help give you some idea of what's going on. So let's run through the problem set quickly. This says, what is it about the following graphed lines that allows us to confirm that they are parallel? So they look parallel, right? So the thing that we're going to want to know about all these lines is, what is the slope? If the slope is the same, then that will confirm to us that they are parallel. So even on these, we can count. Look at this. If we go up 1, 2 over 1, 2, this is an m of 2 rise over 2 run, which is 1. So this is just like in that example in the notes. These all have a slope of 1, so we know they're parallel to each other. And just like that, if you can, think of a slope of a line here, and if we have additional lines with the same slope, they're all going to be parallel. So they all have the same slope. Again, relatively intuitive to students, but now we get to the opposite idea of perpendicular lines. These are lines that cross at 90 degrees right here, and we can put a square in to show 90 degrees, right, and a small square in those corners. And if you think about a circle being here, 90 degrees, 90 degrees, 90 degrees, 90 degrees, this would be 90, 180, 270, and 360 degrees in a circle. So if we look at the equation of this line here, and I'll rewrite it since I started drawing over it, y equals 3/2 x plus 2. And then we look at this one here, and I'm going to again rewrite that. Y equals, what we have here is a negative 2/3 plus 2. And they cross right here at plus 2 on the y-axis, so that's hence the plus 2 here. What we're really focusing in on are the slope of 3/2 and the slope of negative 2/3. So this is the idea of the negative reciprocal, right? Negative because if this is positive, it must be multiplied by a negative to turn to negative, and vice versa. If this is negative, we would have to multiply it by a negative to get back to positive. And the idea of reciprocal, flipping the fraction, where the numerator is, the 3 is in the numerator here, now moving to the denominator position. The 2 is in the denominator position, now moving to the numerator. Basically speaking, we just flip that fraction. Right? So if we have two slopes and they are related by the negative reciprocal, that confirms to us, because they want to know what confirms that these are perpendicular, it's that the slopes have a negative reciprocal relationship to each other. Okay, so now they're going to give us a couple of problem sets where we just find the parallel slopes for them. So given the equation of a line is, and let me rewrite this, it's a little bit hard to see when the fraction's written flat like that, 3/2 x plus 2. That's our fraction. So we need a parallel equation. What do we know about a parallel equation? The slope must be 3/2. We need to match the slopes, they'll all be parallel. So is this one a slope of 3/2? No, negative 2 right here, so that's out. 2 is out. And negative 2/3, that's out. There's only one with a slope of 2/3, so it's got to be this one that is parallel to this one. And again, just like a lot of the other lessons, let's quickly go and confirm this by typing it into Desmos. All right, so here's our given line. Y equals 3/2. So 3 divided by 2 plus 2. All right, there's our first line. And here's the one that we're comparing it to. So let's get rid of this. Go ahead and say y equals 3/2 x minus 3. All right, so notice the two lines. Well, let's adjust this a little. Okay, so now we can see they at least visually, do look parallel to us, right? Why? Because, and how can we confirm it? The slope of one is equal to the slope of the other. 3/2 equals 3/2, okay? So we'll use Desmos just like we've done on a lot of these lessons. We'll go back and keep typing them in to confirm to ourselves what is happening. Now let's move to the other idea we're talking about, which is perpendicular. So given this equation of negative 3/2 x plus 1, we want to select a perpendicular equation. Well, what we need to do is take this slope and find the negative reciprocal. If it's 3/2 now, flipping it would be 2/3. And if it's negative now, multiplying it by a negative would make it a positive. So we're looking for an equation with a positive 2/3 slope. So this one's got a 2 in front of the x, so that's out. A negative 2/3 is out. 3/2 is out. Here's the only one with a positive 2/3 slope, which is, just like y equals mx plus b, right? Which we've dealt with a lot by now. The m is the slope is the value in front of the x. That 2/3 is what confirms it. That's our correct answer for a parallel. And let's go ahead and do this one quickly. If this is a negative 3/2 here, let's match this one to have a negative 3/2 plus 1. Okay, there's 1. And then let's type in this one we're saying it is. So 2/3. 2 divided by 3 plus 5. All right, so let's click home. There we go. Sometimes I can't find. Do they look perpendicular to you? They do to me. And sure enough, it's because the slopes are related by a negative reciprocal. We flipped. The 3 is now in the denominator position. The 2 was denominator, now numerator. And it switched signs. So negative reciprocal, two things happen. And it produces equations that are now of perpendicular lines. Let's do one more example where we find parallel and perpendicular. All right. Y equals 2x minus 3. And we want a parallel equation. Just find anything with a slope of 2. So out, 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 in. There. Now let's do a little bit more difficult. Let's look at the perpendicular setup. So this is y equals 2x minus 3. What we need to do to this is flip the fraction, right? And this can be confusing for students because really it's a 2/1. Now I can understand to flip it as a 1/2. And it was positive before, I'm going to make it a negative. So I need a slope of negative 1/2. Let's look through. 1/2 positive, no. Negative 2, no. 2, no. Negative 1/2. And on this one, let's go ahead and compare this one as one last one on Desmos. Let's put in a 2x, out, 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 out. 2x minus 3. And so now we have a minus 1/2. Minus 1/2 x minus 4. And we better hit home because there it is. Right, so there's our perpendicular lines we created with two different equations, and the relationship between the two is that the slope has been flipped and the sign has been changed, otherwise known as the negative reciprocal. All right, so make sure you're matching up the title of this video with the problem set you're doing, otherwise it's not going to make much sense. This one is called Algebra 1, Semester 1. It's the third unit called Graphing Linears, and it's the 15th lesson called Writing Equations of Parallel and Perpendicular Line Practice. It's on CreatorMath.com under the Algebra 1 tab. Hope this helps.